So welcome to Vedic Maths Part 3, first session. In today's session, we'll be having these four topics: complement and vinculum, which I already done earlier. We'll revise it. Then digit sum, divisibility test, and cross-checking. Then adjusted base method of multiplication. And the last topic, adjusted base method of squaring. The first topic is basically revision because we have done it in the part 2. So let's just revise it quickly. If you just answer quickly, then we can move to the next topic. Okay, all of you know the definition of complement. The two numbers are said to be complements of each other if it adds to next nearest base. So let's just answer, all of you answer the complement in the chat box, answer it privately. Complement of 33. First, answer first. No, Isra, 33. Yes, already forgotten. Okay, Shaina, correct. Isra, correct now. Sairudra, correct. Others, I'd report you that you should revise part 2. So for getting complement of any number, you have to just use all from 9, last from 10. So 9 minus 3 is 6, last from 10, 10 minus 3, 7. 67 is the correct answer. Calculate complement of 84 first. Others, those are not answered, just answer it now. Path. Okay, Sahirudra correct, Isra correct, Ati correct, Shaina correct. Satvik, which one you are answering, Satvik? Path correct. Satvik, which answer you are giving? This is a complement of 84 is asked. The rule is all from 9, last from 10. Subtract all from 9, last from 10. 9 minus 8 is 1. Last from 10, 10 minus 4 is 6. Is it clear, Satvik? Just confirm that you are clear. You're giving answer which is not related. Try to answer it privately first thing, all of you. So do the answer of this. Complement of 2894 first. Answer privately. Answer to me only. Yeah, Isra, very good, correct. Shaina, correct. Sairudra, correct. Arti, correct. Parth and Satvik has not answered. Any doubt? Parth, Satvik. Just you have to use all from 9, last from 10. 9 minus 2 is 7. 9 minus 8 is 1. 9 minus 9 is 0. And last from 10. Any doubt, Satvik and Parth? All from 9, only last from 10. Okay, I want answer from Satvik and Parth. 4849 first. I want Parth and Satvik to answer this first. Just all from 9, last from 10. Yeah, Parth correct. Satvik, you got your answer? Satvik, if you got any difficulty, you can ask. Okay, correct. I want answer from Satvik. So we just subtract all from 9, last from 10. 9 minus 4 is 5. 9 minus 4 is 5. All from 9, Satvik. Only last from 10. So it should be 5 here. 9 minus 4 is 5. 9 minus 8 is 1. 9 minus 4 is 5. And last from 10, 10 minus 9 is 1. If you add this, you will get 1 followed by 4 zeros. Like this, you try and check practice number of problems. Take any number, find complement. If you add, answer should be 1 followed by zeros. Okay, Satvik, practice. Now, if there are zeros at the end, all of you see, if there are zeros at the end, there's zeros remains as it is. And for remaining part, you apply all from 9, last from 10. So 9 minus 8 is 1, last from 10, 10 minus 7 is 3. Okay, zeros at the end will remain as it is. And for remaining part, you apply all from 9, last from 10. So calculate this now first. 650, all of it. Yeah, Isra correct, Parth correct, Shaina correct, Sairudra correct. Satvik correct. Good. So zeros remains as it is, and then remaining you use all from 9, last from 10. 9 minus 6 is 3, last from 10. 10 minus 5. Try this. 87900. Yeah, Isra very good. Parth correct, Sairudra correct, Shaina correct. So those 2 zeros, Satvik correct. 2 zeros will remain as it is, and for this part you have to use all from 9, last from 10. 9 minus 8 is 1, 9 minus 7 is 2, and last from 10, 10 minus 9 is 1. Okay. Next you should know complement of single digit. This you should know by heart. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so as per the rule, all from 9, last from 10 is a single digit, last digit. So subtract from 10. 10 minus 1 is 9, 10 minus 2 is 8, then 7, then 6, then 5, then 4, then 3, then 2. Now within this, what is important is this, which is required for the next topic, Vinculum. So we'll convert any number by removing this digit by using its complement. Instead of 6, we'll use 4. Instead of 7, we'll use 3. Instead of 8, we'll use 2. And instead of 9, we'll use 1. And get any number without digit 6, 7, 8, 9. So that we'll achieve by using Vinculum. So let's just revise Vinculum. Again, Vinculum we are done thoroughly in part 2. So if you have any digit above 5, that can be converted. Now this is a normal number. We'll convert to Vinculum. First, very important part what we should understand is Vinculum will be useful when you have got digits above 5. If all digits are less than 5, you don't need to use Vinculum. So start from rightmost digit. Wherever you have digit above 5, you have to take complement. So basically, you'll require to use this. So here 9 is above 5, take complement, put dash, add 1. This 2 will remain as it is. So 2, 2 bar 1 is the Vinculum of 219. Calculate Vinculum for this. Right answer without bar, I'll assume bar. So now if you have to answer this, you will answer 221. Yeah. Isra correct, Parth correct, Sairudra correct, Shaina correct. Good. Satvik, any doubt? See here. 2 will remain as it is. You have to start from rightmost digit. Only digits which are above 5 will convert. 7 is above 5. Take complement. Complement of 7 is 3. Put dash. Add 1. Any doubts, Satvik? Try this 2916. Yeah. Parth correct, Sai Rudra correct, Shaina correct, Isra correct. 6 is above 5, take complement. Complement of 6 is 4, put dash, add 1, 1 plus 1 is 2. 9 is above 5, take complement, put dash, add 1. Okay, Satvik, correct. Now try this. 817. 817. Isra correct. Shaina correct. Sai Rudra correct. Parth, you have to try again. Satvik, you have to try again. T correct. Now Parth. Mm, okay, Satvik correct. Parth here. 7 is above 5, so take complement. Put dash, add 1. 1 plus 1 is 2. 8 is above 5, so you'll have to take complement. Complement of 8 is 2. Put dash, add 1. Nothing is 0. 0 plus 1 is 1. Okay, 1 bar 2, 2 bar 3. Okay, Parth, any doubt? Try this. Okay, try this, Parth. 296 next. Yeah, Shaina, correct. Isra, correct. Satvik, correct. Yeah, 6 is above 5, take complement. Complement of 6 is 4. Put dash, add 1. 9 plus 1 is 10. When you get 2 digit, you have to write last digit. Extra digit, you have to carry. 2 plus 1, 3. Okay, 30 bar 4. Try this now. 2793. Yeah, Shaina, correct. Good. Satvik, you have to convert that 8. No, Parth, you have to convert that 8. Yeah, Isra, correct. Arti, correct. Parth, still there is slight mistake. Sai Rudra, you have not answered. See, Parth, Satvik, 3 will remain as it is. 9 is above 5, so take complement, put dash, add 1, so this becomes 8. So you take complement of 8 and not 7. Complement of 8 is 2. Put dash, add 1, 2 plus 1, 3. Satvik, Parth, is it clear? Sai Rudra, you have not answered. Okay. So try this. 3, 7, 8, 4. 3, 7, 8, 4. Yeah. China correct, Isra correct, Parth correct, Karthik correct, Sai Rudra correct. 4 will remain as it is. 8 is above 5, so take complement. Yes, Satvik correct. Add 1, so this becomes 8, so complement of that is 2. Put dash, add 1, 3 plus 1, 4. So next, you should know the reverse. Just to save time, we'll just try and convert this only back to normal. And we all already discussed this, that you can try like this any number of examples. Okay, so one, for converting vinculum back to normal, start from rightmost digit. Wherever digit is negative, you take complement and reduce one. Okay, when you are moving from normal to vinculum, you are increasing one. Here it is reduce. One negative, take complement, reduce one. 2 minus 1 is 1. 2 will remain as it is. So you got back the same number. Okay, so that way you can try like this and check yourself. As long as you get back the normal number, it is correct. 2 as it is, 3 negative, complement of 3 is 7, reduce 1, 4 minus 1, 3. So same. Take this, 4 negative, take complement, reduce 1, 2 minus 1 is 1, 1 negative, take complement, reduce 1, 3 minus 1, 2. 2916, 2916. 3 negative, take complement, 7, reduce 1, 2 minus 1 is 1, 2 negative here, take complement, complement of 2 is 8, reduce 1 is, this will become 0. If you want, you write 0, otherwise it's very clear that answer is 817. 4 negative, take complement, reduce 1 is, this will become minus 1. So you have to take complement, complement of 1 is 9, reduce 1 is 3 minus 1, 296. Next, 3 will remain as it is. 1 negative, take complement, complement of 1 is 9, reduce 1. It is minus 2 right now, minus 1 will give minus 3. So this will become minus 3. So you take complement of 3, that is 7, and then reduce 1 is 3 minus 1, 2. 279. Last 4, 2 negative, take complement, complement of 2 is 8, reduce 1. As we have discussed here, this will be minus 3, complement of 3 is 7, reduce 1, 4 minus 1, 3. Any doubt in vinculum back to normal? Now further, we have seen that if you have got a continuous negative number, then instead of doing this, see now in this case, there are continuous, there are two negative numbers. So what you can do is, this 3 is positive, that you are writing as it is. For this 21, you can use all from 9, last from 10 within this, and reduce one previous digit, previous to this continuous negative numbers. 9 minus 2 is 7. This is the last now, last from 10. 10 minus 1 is 9. All from 9, last from 10. And then reduce 1. So if you have got a continuous negative digit, this will be faster than our normal method. Okay. So here 4 will remain as it is because that is positive. And for 2, 2 you use all from 9, last from 10. 9 minus 2 is 7. This is last from 10. 10 minus 2 is 8. And then you have to reduce previous digit by 1. 4 minus 1, 3. So if you have got a continuous negative digit, definitely this method will be faster than our normal what we are converting digit by digit. Any doubt in understanding this? There is no much difference when there is a in between negative digit. Only when there is a continuous negative digit, you will find that this is faster. Any doubt you can ask, otherwise we are moving to next topic. Parth Satvik, practice number of problems. See, this is how you can practice any number of problems. Take any number, convert to vinculum, take that number and convert back. As long as you are getting back the same number, your calculation of vinculum number is correct. Okay, so that is just was a revision of complement and vinculum. Now, digit sum we have covered actually in part 1. It is not there in part 2. Divisibility test also partly covered in part 1. Cross checking is new topic. So let's start with this. First, we'll start with the digit sum. So this was in part 1. Digit sum of a number is a single digit. Answer has to be 1 to 9, which you get by adding all digits of the number. Okay, so let's calculate number digit sum. Okay, so if number is say 42, so you will just add 4 plus 2, 6. Okay, digit sum of 42 is 6. If you consider number say 17, digit sum will be 1 plus 7, 8. If say number is 2, 4, 3, 2 plus 4 plus 3, 6 plus 3, 9. If number is say 85, 8 plus 5 is 13, but 13 cannot be digit sum. You can see the definition here. The answer has to be 1 to 9. So you have to continue adding. So 1 plus 3, 4. So digit sum of 85 is 4. If you consider this number 1 plus 9 plus 2, 10, 12, and then 1 plus 2 gives you 3. Now here is a shortcut. When you have got 9 or any combinations of 9, you can cancel that. It does not change digit sum. So cancel this 9 and you can see the answer is same. 1 plus 2 is 3. Okay. So next also note that if you have got a combination also, you can remove just not only 9 combination which makes it 9. 6 plus 3 is 9, so you can remove this combination. 6 plus 3 9, so 2 plus 4, answer is 6. Okay, so 9 and any combination of 9 you can remove, and then remaining part you have to add. Now if you consider this number 999, now if you use this method, 9 cancelling 9, if you cancel all 9 it looks like 0, but again note here that answer has to be 1 to 9. So when it is 0 it is actually 9, or in other words, if you use normal method what we have learned here, 9 plus 9 plus 9 is 27 and 2 plus 7 is 9. So in short, you just note that when all are 9, answer is 9. Okay, any doubt? Can we move to the next? Within this, next is divisibility test. Based on digit sum, we'll have two divisibility tests, which we had covered in part 1, and we'll learn more divisibility tests. So let's go through divisibility tests, some of which you already studied. Divisibility test for 2. Okay, to decide whether number is divisible by 2 or not. Okay, the rule is number is divisible by 2 if last digit of number is 0, 2, 4, 6, 8. For 3, we can use concept of digit sum, which you have just learned. If digit sum is 3, 6, or 9, that number is divisible by 3. For 4, it is like this. If number formed by last 2 digit, any big number, say if you consider a big number like this. Okay. So if you want to check whether this is divisible by 4, you just check this 84, whether it is divisible by 4. Okay. 84 is clearly divisible by 4, so the full number is divisible. That is what it says. If number formed by last 2 digit, any big number it may be, just check the last 2 digit. If last 2 digits are divisible by 4, the entire number is divisible by 4. This is known to you. For 5, if last digit of number is 0 or 5, then it is divisible by 5. For 6, we have to use combination of this 2 and 3. So that means here digit sum should be 3, 6, or 9, and the last digit should be one of this. If both this is satisfied, number is divisible by 6. Any doubt so far? Now we'll study 7, that is new for you. Now, if you just read this, it says to check whether number is divisible by 7, double last digit and subtract from remaining number. If resulting number is divisible by 7, then the original number is divisible by 7. Okay, we'll check it with the example. Consider the number 393. 6, take the last digit, double it. 3 into 2 is 6. And then this you have to subtract from remaining part. That means 39 is remaining here. 39 minus 6. 9 minus 6 is 3. 33, and you know that 33 is not divisible by 7, or 33 is not in the table of 7. So this is not divisible by 7. So this number is not divisible by 7. Let's take next example, 392. The method is take the last digit, double it. 2 into 2, 4. Last digit here 2, double means multiply by 2, 2 into 2, 4. And then subtract from remaining part. Remaining part here is 39. 39 minus 4 is 35. And you know that 35 is divisible by 7. 7 5s are 35. Because this is divisible by 7, the original number is divisible by 7. Another example, 3192. Take the last digit, double it. Subtract from remaining part. Remaining part here is 319. 9 minus 4 is 5. This one remains as it is 3. Now 315, you cannot decide directly whether it is divisible by 7. So repeat this procedure. Okay. In previous example, in the first attempt only, we had taken a decision. Here at this stage, you cannot take a decision. Repeat same procedure. Take the last digit, double it. Okay. So, and then subtract from remaining part. Remaining part here is 31 minus 10 is 21. And you know that 21 is divisible by 7. 7 3s are 21. So because this is divisible by 7, this original number 3192 is divisible by 7. Okay, so that completes divisibility test for 7. 8, it is like 4 here, but in 4 we are checking last 2 digit. Here it is last 3 digit. If number formed by last 3 digit is divisible by 8. Okay. For example, if you consider 2, 8, 3, 9, 0, 1, 6. Consider such a big number, but what you have to check here, as it says, is last 3 digit. 0, 1, 6. Now 0, 1, 6, that is 16 actually, is divisible by 8. Because this is divisible by 8, the full number is divisible by 8. If number formed by last 3 digit is divisible by 8, then the full number is divisible by 8. So you just check the last 3 digit. If it is divisible, like in this case, just at a loop, you can know that it is divisible by 8. Otherwise, you divide and check quickly if you cannot identify directly. Okay, so we'll go to the 9 is very simple, because that is based on digit sum. Just now we have calculated digit sum. If the digit sum is 9, number is divisible by 9. 10 is very simple. If last digit is 0, number is divisible by 10. Okay, let's try 11. I'll take some example for 11. So let's take this example, 5016. So what it says, if difference between sum of odd digits and even digit is either 0 or 11, it is divisible by 11. Now you can start from here or here, both ways it is okay. Accordingly, you take odd numbers. Now if you are starting from left, this is the first odd number, this is second odd number. This odd position, this is first digit, this is third digit, and this is second digit, and this is fourth digit. So you have to add digits at odd position, you have to add digits at even position, and check the sum. 5 plus 1 is 6, 0 plus 6 is 6, and if you subtract, You get 0. So because it is 0, this number is divisible by 11. Add all digits at odd place, add all digits at even place and subtract. Answer should be either 0 or 11. Then the number is divisible by 11. Let's take another number 92961. Okay, so if you start from left, first, third, and fifth, you have to add this 9 plus 9 plus 1. 9 plus 9 is 18 plus 1, 19. And the second and fourth, 2 plus 6 is 8. And if you subtract 19, 19 minus 8, it gives you 11. So this number is divisible. Add all digits at odd place, add all digits at even place, and subtract. And if you get 0 or 11, number is divisible by 11. Any questions? So let's go for 13. For 12, it will be divisible by 4 and 3 combination, like how we have here 2 and 3. 4 and 3 combination we'll have to check. So 13, what it says is multiply last digit is similar to this 7. Just understand it's similar, only difference is here to multiply by 9. Here you are multiplying by 2, double. Double means multiply by 2. Here it is 9. Multiply last digit by 9 and subtract from remaining. Similar concept. So let's take this example, say 5612. Take the last digit, multiply by 9. Gives you 18. Subtract that from remaining part. Remaining part here is 561. So we'll have to carry here 11 minus 8 is 3. What remains is 5 here. 5 minus 1 is 4. So you cannot decide. So repeat. 3 you have to take and multiply by 9. 3 9s are 27. And if you subtract 14 minus 7 is 7. What remains is 4. 4 minus 2 is 2. 27. Now you can clearly take a decision that this is not divisible by 13. 13 into 2 is 26. So this is not divisible by 13. So this is not divisible by 2. So let's take another example. Say 2028. Take the last digit, multiply by 9. Subtract that from remaining part of the number, that is 202 in this case. 2 minus 2 is 0. You have to carry here 10 minus 7 is 3, and then what remains here is 1. 130 is very clear. 13 into 10 is 130. So this is divisible by 13. That's why this number also is divisible by 13. Okay. 13 into 10 is 130. Next, another example, say 6656. Take the last digit, that is 6, multiply by 9. 6 5s are 54. Subtract it from remaining part of the number, that is 665 here. 5 minus 4 is 1. 6 minus 5 is 1. 6. So you cannot decide. So continue the procedure. Take 1, multiply by 9, gives you 9. Subtract from remaining part. Okay. So here carry 11 minus 9 is 2. What remains here is 5. And you know that 13 into 5 is 52. 13 5s are 52. So 52 is divisible by 13, and that's why this number is divisible by 13. Okay, any questions? Any doubt? Yeah, correct. Correct, Isra. Thank you. Yeah, that was a mistake. Thank you, Isra. 13, not 5. This is 13. 4. Thank you, Isra. Yeah, Shaina also has indicated. Good. Good that you are very attentive. That clearly indicates. Okay, I put 13 5 it's 52. It is 13 4 13 4 is 52, not 5 is 65. So because 52 is multiple of 13, you can conclude that 6656 is divisible by 13. Yeah, thank you, Isra and China. Isra has asked one doubt. Let's try that. All of you try this and tell me whether it is divisible by 13. This was doubt asked by Isra. Thank you, Isra, for asking doubt. 169. Check whether it satisfies the rule what is told here or what we have just tried here. If you are getting confirmation, I think all of you know that this is divisible by 13, but 13 into 13, 13 square is 169. So just confirm whether it follows this rule what we are referring. This is a doubt asked by Isra. Thank you, Isra, for asking this doubt, because of this doubt, we'll learn something more. Anybody is getting? Just say yes if you are getting that it is. First thing, note that this is 13 square, so it has to be divisible. So question is whether you get just looking at this, because you know 13 square, you can easily say that. But the question is whether this method is satisfying this whatever rule we have put, or what difference the final answer you get, whether it is divisible by 13. Now in this case 52 is divisible by 13, and that's why we said 6656 is divisible. So that way whatever answer you get after performing the steps here, you should get a number which is divisible by 13, and then only you can conclude that 169 is divisible by 13. Just confirm if anybody is getting this rule satisfying. Just say yes or no at least in the chat box. Yeah, very good, Shaina. That's correct. Very good. Okay, see you now. Isra, just concentrate because this is your doubt. Take the last digit, that is 9, multiply by 9, you get 81. So that 81 you have to subtract. So 16 minus 81. So you are sure that you get negative answer. So do just 81 minus 16. 11 minus 6 is 5. What it means is here 7. 7 minus 1 is 6. So answer here is minus 65. Okay, so we don't have to check the sign. 65 is divisible by 13. 13 into 5 is 65. So because this is divisible by 13, this 169 is divisible by 13. Sir, your doubt is clear? Just confirm. So with this, because Isra asked this doubt, all of you understood that this can be negative also, the final answer here. But we are not checking that. We're checking number whether it is divisible by 13, then okay. So that completes our divisibility test. And then the third part within our second topic is cross-checking. Okay, try more examples yourself. You have to try a number of examples. Okay, next we are going to study how to cross-check using digit sum. Now, note that this digital root is another name for digit sum. Okay, so digit sum and digital root refers to same thing. Digital root is another name for digit sum. Okay, now just we'll go through the steps. Find digital root of each number. This is like how to cross-check. If you've done some operation and you want to check whether that is correct, it is possible to check by using digit sum. So it says here it is written as digital root. Note that they are same. Digit sum and digital root are same. Find digital root of each number involved in the operation. Second step, perform same operation on digital roots. And then calculate and compare digital roots of both answers. If they are same, then it means that the calculation is correct. For example, just consider this 52 into 58. I hope all of you know that the answer of this is 3016. 5 into 630 is a multiplication special case which we have covered in part 1. 5 into 6 is 30, 2 into 8 is 16. That is the answer. This is what we have done, and we want to check whether this is correct or this answer is correct. First step, find digital root of each number. Digital root of 52 is 7. Digital root is 58. 5 plus 8 is 13. 13 means 1 plus 3 is 4. So first step is done. We have found digital root. Next it says perform same operation on digital root. Now this is a multiplication. Perform multiplication. 7 into 4 is 28. And then it says calculate and compare digital roots of both answers. Digital root of this 3 and 6 will go as 9 and answer is 1. Here 2 plus 8 is 10. 10 is 1 plus 0 is 1. So both digital root answer is same 1. As the digital root of both answers are same, our calculation is correct. Okay. You can copy these steps. If you got any doubts, anybody wants me to repeat, just say repeat in the chat. See here how it can be useful. Like say, if you consider that in your competitive exam, you have got options like say 3018, 3017, 3015, and 3016. Okay. So you know that digital root of this is 3. Digital root of this is 2. This is, so it's 8 plus, yeah, 2. Then here it is 4 plus 5, 9. And this is 6 and 3 goes, so answer is 1. Now, if you just, instead of doing this, now this is very simple, easily you can do it, but just imagine that it's complicated calculation is given. Instead of doing this, this is doing this is easier, calculating on digit sum, because that will be single digit. And that digit sum of that answer you know is 1, and 1 is matching here, and with that you can conclude that this is the answer. This is how you can make use of this cross checking using digit sum for competitive exam, where you get options. Just find the digit sum of each answer and check which matches with this digit sum. Any questions? We'll take some more examples. You can just copy these steps and just sit down. I'll take some more examples on this. Just sit down if you have finished copying. So Others are not finished. I only got answer from Isra and Parth. Okay, so we'll try and more example. Say addition is what we just tried was multiplication. Say if we have some addition problem, 3 plus 8 is 11, 1 carry 1, 5 plus 2, 7 plus 1, 81. So first step, and this is what we have done, and you want to check whether this is correct. It's a very simple example, but then we are learning the method. The digit sum of 53 is 8. Digit sum of 28, 2 plus 8 is 10. 10 is 1. Perform same operation. First step is find digit sum or digital root of both the numbers or all the numbers involved in the operation. Then perform same operation. 8 plus 1 is 9. So digit sum of 9 is 9. Single digit remains same. Here 8 plus 1 is 9. Both answers digit sum are matching. So our calculation is correct. Okay. So let's take say 82 minus 53. Subtraction. Okay, so digit sum of 82, 8 plus 2 is 10. 10 is 1. 53 is 8. Perform same operation. Here it is subtract. Okay, before that I have not completed this subtraction. Let's complete this first. So we'll have to carry here 12 minus 3 is 9. What remains is here 7. 7 minus 5 is 2. So answer is 29 here. So perform same operation. First step, calculate digit sum or digital root of all the numbers involved in the operation. Here there are the only two numbers involved. Digit sum of 82 is 1, 53 is 8, and then subtract 1 minus 8 is minus 7. Now digit sum of this is 2. Okay, 9 is cancelled, answer is 2. Now here it is minus 7. Now note that digit sum answer, as we have discussed in the definition, has to be 1 to 9. Okay, so it cannot be other than that. If at all in the calculation you get the other answer, like say 0, then you have to add 9 to get actual answer. Okay, so it cannot be 0. 0 plus 9 is 9. Same way, if it is negative, again you have to add 9. Minus 7 plus 9 is 2. So it is matched. Okay, answer of digit sum has to be 1 to 9. If you get 0 or negative, add 9 to get actual digit sum. Okay, so any doubt? Okay, so we have completed first two topics, complement, Vinculum revision, then digit sum, divisibility test, and cross-checking is what we have just finished. Now we'll move to adjusted base method of multiplication. Adjusted base method of multiplication. Okay, you already studied base method of multiplication. Now this is by adjusting base. So actually, you know that base can be 10, 100, 1000, 10,000, and so on. Now what we'll do is base method of multiplication. What we have learned or what we already done is if number is near to one of this, now we'll consider number is near to multiple of this base. Instead of 10, it will be near to 20 or 30 or 40 and so on. instead of 100 near to 200 or 300 or 400 and so on. Same way 2000, 3000, 4000 and so on. Same way 20,000, 30,000, 40,000 and so on. So instead of near to the base, it is near to multiple of base. And for that, we have to adjust the base. Okay, that's why the method name is adjusted base method of multiplication. For example, let's take this example, say 23 multiplied by 22. Now this, note that this you can do easily using crisscross, but we are taking simple example to understand the method. Now this, if you want to use base method, it is not near to 10. Neither it is near to 100. Okay, normal base method, it has to be near to 10 or 100 or 1000. So, but then if you just note carefully here, both numbers are very near to 20, which is multiple of 10. Okay, so here base will remain as 10 only, whereas adjusted base instead of 10 will take 20. Now, whenever you take adjusted base, you have to find relation with the main base. Main base is 10 here. So 10 multiplied by 2 gives you 20. So this is called relation of adjusted base with main base. Okay. So next, find difference. 23 minus 20 is 3. 22 minus 20 is 2. Put the line to separate left hand side and right hand side. As you know, right hand side, you just have to multiply these differences. 3 into 2 is 6. Base has got 1 0, so one digit is correct here. Cross addition, 23 plus 2 is 25. Okay, so these all steps are same as you learned for base method of multiplication. Only extra step which you require to perform in adjusted basis, whatever relation you get here with the main base, that you have to apply on the left hand side of this answer. That is into 2. So you have to perform that on the left hand side. 25 into 2 is 50. So that is the left hand side answer. Right hand side answer is 6. So answer of this multiplication is 506. So only extra part is this, finding the relation with the main base, and that you should apply on the left hand side. Otherwise, all steps are same as normal base method of multiplication. Any doubts? Any doubt anybody wants me to repeat? Just say repeat in the chat. If you don't have doubt, do this 42 into 43. 42 into 43. Right answer in chat box. Good, Arti, correct. Arti, you have followed the method, no? China, correct. Sai Rudra, correct. Okay, base here, Sira, correct. Base here again is 10. Adjusted base will be 40. Both these numbers are very near. Multiple of 10 if you want to take, they are both near to 40. The relation is very clear with the main base 10 into 4 multiplied by 4 is our relation. Find difference with this adjusted base. 42 minus 40 is 2. 43 minus 40 is 3. 2 into 3 is 6. Base has got 1 0, so one digit on the right hand side is correct. Cross addition, 42 plus 3 is 45. Perform this operation on the left hand side into 4. 4 5s are 20, so 0 carry 2. 4 4s are 16 plus 2, 18. Join, and that gives you answer 1806. Anybody has doubt? Try this. 43 multiplied by 44. Yeah, Isra, very good, correct. Only Isra has done so far. Yeah, Shaina, correct. Sai Rudra, correct. Base is 10, adjusted base will be 40, both numbers. Satvik, Satvik, you have to try again. Arti, correct. Okay, Satvik's here. Satvik parts here. 40, that can be written in terms of main base as 10 into 4 into 4 again. Parth and Satvik just here. This is 3. 43 minus 40 is 3. 44 minus 40 is 4. 3 into 4 is 12. Cross addition, 43 plus 4 is 47. 47 into 4 multiplied by 4. 7, 4 sevens are 28. 8 carry 2. 4 fours are 16 plus 2, 18. Now, very important part which was studied, that number of digits on the right hand side should be equal to number of 0 in the base. Base has got only 1 0, so this is extra that you have to add. Not that extra you have to add after performing this operation. So plus 1. So left hand side is 189 and answer is 189 and right hand side digit is 2. Okay, correct part. Satvik, clear with your mistake? Satvik, just confirm. Okay, Satvik. So next I'll show you one example where it is possible to solve in two different ways. Consider this example, 52 multiplied by 54. Okay, I'll solve it in two different ways of adjusted base method. First, as we have discussed here, base is 10, adjusted base is 50, relation is 10 into 5. Difference 52 minus 50 is 2, 54 minus 50 is 4, multiply differences, that is 8, cross addition 52 plus 4 is 56, apply this relation to the left, into 5, 5 6 are 30, 0 carry 3, 5 5 are 25 plus 3, 28. Okay. 1 0, 1 digit, so it is correct. Just join and answer is 2808. Okay, now I'll take the same problem and see how we can solve it by taking base 100. Now here we have taken main base is 10. Instead of that, you can take 100. Adjusted base will remain same because only when you take this 50 here, this difference is simpler to multiply. Okay, but now here relation will be different. Now you have to set the relation with reference to 100, and that you can write 100 divided by 2. Okay, so difference here is 2, here it is 4. Multiply differences, that gives you 8. But note that there are 2 zeros in the base, so you have to write 08. Cross addition 54, 52 plus 4 is 56. And now here relation is divide by 2. Okay, so relation here is 56 divided by 2. 56 divided by 2 is 28. And then join 2808. Okay, so same answer. If you got any questions, you can ask. So when it is near to 50, you have got two options to solve. You can take base 10 or base 100. Same way, if it is near to 500, you can take 100 or 1000. Try this 213 multiplied by 204. Isra, check right hand side. I think you have taken instead of 13, 3. China, correct, good. Isra, you have taken 3 difference here instead of 13. Difference here will be 13. Check, Isra. China got correct. No, Sairudra. Isra correct now. Sairudra, you try again. Sairudra, you got totally different answer. How it can be? No, Satvik. Okay, check here. Base 100. Ati, there is some mistake. Base 100. Adjusted base is very clear, 200. Only when it is 200, these differences will be very simple. 213 minus 200 is 13. 204 minus 200 is 4. 13 into 4 is 52. 13 into 4 is 52. Two zeros, two digits. So we are getting required digits. Cross addition. 13 plus 4 is 17. 217. 213 plus 4, 217. The relation here is 100 into 2. Relation the main base. Main base is 100. 100 into 2. So into 2. That you have to apply on the left hand side. 2 into 7, 14. 4 carry 1. 2 into 1 is 2. Plus carry 1 is 3. 2 into 2 is 4. So 4, 3, 4 on the left hand side. We have confirmed that number of digits are correct here. Just join. Correct. 2, 4, 3, 4, 5, 2. Any doubt, Satvik? Sairudra, you have checked what is the mistake? Check where you went wrong because you are showing some totally different answer. Any doubt? Anybody wants me to explain again this? Tell fast. Just say repeat. Sairudra, Satvik, just confirm that you understood. Okay, Sairudra, try this now correctly. 3023 3004. Yes, Satvik, I have put the example already. So here it is near to 3000. Arti, very good, correct. Isra, you have to try again. Isra, how do you got that answer? Shaina, correct. Arti and Shaina got correct. Sairudra, Sairudra, you are not taken care of number of digits on the right hand side. Number of digits on the right hand side. Isra, your mistake is you added differences. Differences we always multiply, no? Isra, you have done this addition. Addition also. 20. Yeah, you have done addition. Sorry, it's here. 23 plus 4, 27. It is 23 into 4. Isra, understand your mistake. Part no. Satvik, correct. So base here is 1000. Okay, this is multiple of 1000. This is near to 3000. So it is multiple of 1000. So adjusted base will be 3000. Relation is very clear. 1000 into 3 multiplied by 3 is the relation. Difference 3023 minus 3000 is 23. 3004 minus 3000 is 4. No part, just see per part concentrate. So multiply this 4 3s are 12. So 2 carry 1, 4 2s are 8 plus 1 9, 92. 3 zeros. So very important, you should have 0 here because you want 3 digits on the right hand side. Cross addition 23 plus 4 is 27, 3027. And then apply this relation into 3. Okay, 3 into 7 is 21, 1 carry 2, 3 into 2 6 plus 2 8, 3 into 0 is 0, 3 into 3 is 9. Okay. Then just join 908109. Okay, part just confirm whether you understood. Maybe you multiplied something else. Multiplied by 4. Okay. Okay, so this was adjusted base method of multiplication you have to use when number is near to multiple of base. Okay. So similar way is the next topic, adjusted base method of squaring. Okay, we'll move to the next topic, the last topic of session. Okay, so we have finished adjusted base method of multiplication. The last is adjusted base method of squaring. So it's the same thing as you already know that base is 10, 100, 1000 and so on. Whereas adjusted base will be 20, 30, 40 or 200, 300, 400. Okay. Similar concept as we just studied. Okay. Instead of 10, multiple of 10. Instead of 100, multiple of 100 and so on. So if you have any number which is near to multiple of base, then you can use this method. For example, like simple example, we'll take 23. 23 we already done using squares of any 2-digit number. You can do it easily, but then let's see whether you can use here adjusted base method because you clearly know that 23 is very near to 20. Okay, so method is take the number as it is, find difference. Here adjusted base will be 20 and relation is 10 into 2. Into 2 is relation. Sorry, take the number as it is. This is not 20, this is 23. Method for adjust base method of squaring is take the number as it is, take the difference. 23 minus 20 is 3. The other side we are writing square of difference. 3 square is 9. Just I'll repeat, take the number as it is, write difference with this adjusted base. Now 23 minus 20 is 3. The other side, right hand side, we are writing square of difference. 3 square is 9. You have to add this. 23 plus 3 is 26. Now only extra thing which you have to do here, considering base method of squaring, is this relation you have to apply on the left hand side. So into 2, 2 into 6 is 12, 2 carry 1, 2 into 2 4, plus 1 is 5. So 52, right hand side base is 10, so that is a correct, only single digit. So answer is 529. Any doubt? Try 32 square with this method. Yeah, it's correct. Correct. Sairudra correct. Shaina correct. Take number as it is. Difference adjusted base here will be 30. Relation will be 10 into 3. 32 minus 30 is 2. Square of difference, 2 square is 4. Okay. So 32 plus 2 is 34. Relation is into 3. 3 4s are 12, so 2 carry 1, 3 3s are 9, plus 1 is 10. Base is 10, so there should be only one digit. So join, and answer is 102. Satvik correct. Try 48 square. Take adjusted base as 50. No, Isra. Try again, Isra. Correct. Very good, Isra. Correct. No, Arti. Arti. Difference there will be 2 minus 2. We have taken 8, Arti. No, Parth. Okay, check here. 48. So we have taken adjusted base as 50. No, Satvik. Adjusted base is 50. So relation is 10 into 5. 48 minus 50 is minus 2. Minus 2 square is 4. 48 minus 2 is 46. Apply this into 5. 5 6 are 30. 0 carry 3. 5 4s are 20 plus 3 is 23. Base is 10, so one digit is correct. So just join 2304. Try 49 square. I wanted all should get correct. Yeah, Arti correct. Isra correct. Shaina correct. Satvik no. Sairudra correct. Satvik's here. Number is 49. 49 minus 50. Adjusted base here is 50. Relation is 10 into 5. 49 minus 50 is minus 1. Minus 1 square is 1. 49 minus 1 is 48. And you have to just apply this into 5. 48 into 5. 5 is a 40. So 0, carry 4. 5 4s are 20 plus 4, 24. Okay. Base is 10, so one digit is correct. So just join 2401. Any doubt? Satvik, any doubt? Okay, Satvik, let's see. Next problem. 4996 square. 4996 square. So base, adjusted base here is 5000. Yeah, very good, Shaina, correct. Shaina, what is the main base you have taken? Just write main base. Arti, correct. No, that is adjusted base, Shaina. Main base. Solve it by taking main base 10,000, Shaina. Yeah, Shaina, Arti, you solve it again by taking main base as 10,000. Satvik, correct, good. Isra, correct, good. Okay, see here. 4996 square. Take number as it is, 4996. Difference is minus 4. Just 4 less to 5000. Our adjusted base here is 5000. So relation is 1000 into 3. Sorry, not 3, 5. Okay. 1000 into 5 is 5000. Minus 4 square is 16. Main base here is 1000. 1000 has got 3 zeros, so 1 zero you require. So 4996 minus 4 is 4992. Then apply this into 5. 5 into 2 10, so 0, carry 1, 5, 9 are 45, plus 1, 46, carry 4, 5, 9 are 45, plus 4 is 49, so 9, carry 4, 5, 4s are 20, plus 4 is 24. 24960, that is left hand side answer. We already confirm the right hand side by putting 0. So just join 24960 Hmm. Good sign, huh? Good earth. Let's solve the same thing. Two students have already solved, China and Arti, by taking main base as 10,000 instead of 1,000. Here what we have done is main base is 1,000. It could be 10,000 also. 10,000 divided by 2 also gives you 5,000. So let's take the same example. Adjusted base is 5,000. Whether you take main base is 1,000 or 10,000, adjusted base will be 5,000, because only with 5,000 this will be very near. So here relation will change by taking base 10,000. 10,000 divided by 2 is the relation here. So 4996, difference is -4. -4 square is 16. Now here base is 10,000. 10,000 is got 4 zeros, so 2 zeros will be required here. As base has got 4 zeros. 999, sorry, 4996 minus 4 is 4992. And then relation here is divide by 2. Okay. So 4 divided by 2 is 2. 9 divided by 2 is 4. Carry 1. So you get 19. 19 divided by 2 is 9. Carry 1. So 12 divided by 2 is 6. Okay. And then join right hand side. 2496001. Any doubt? Anybody who wants to repeat, just say repeat. Thank you.